Bismillahirrahmanirrahim. In the today's lecture, I would like to discuss to you about the higher order differential equations. There are two types of higher order differential equation. Uh, One is homogeneous differential equation, and other is non-homogeneous differential equation. And how we can recognize the different homogeneous uh, differential equation and non-homogeneous differential equation. So here you can see that in the first form here, uh, look at one, look at that the equation an dny upon dx n plus a2 differential n minus 1 y differential n minus 1 अप टू ए नॉट वाई इज इक्वल टू ज़ीरो. सो ये जो डिफरेंशियल इक्वेशन आपको गिवन है इसमें आप देखिए क्योंकि आपके पास राइट हैंड साइड पे ज़ीरो है, सच अ काइंड ऑफ इक्वेशंस आर नोन एज homogeneous differential equation. So here are some examples of the higher order homogeneous differential equations. If you have the degree of differential order more than one in a differential equation, so such a kind of equations are known as higher order differential equations. So in this example, look at that. We have first equation 3 d2y upon dx square minus 2 dy upon dx plus 5y is equal to 0. This is the first example. So the higher order of the differential is second, so it is called second order differential equation. And the other example number 2, we have 4 d3y upon dx cube minus 3 d2y upon dx square plus 2 dy upon dx minus 3y is equal to 0. So in this differential equation we have the higher order 3, so this equation is known as third order differential equations. So solution of the higher order differential equation is based on its polynomial when we generate an characteristic equation from this equation provide us the several roots. The solution of the homogeneous differential equation based on the polynomial or the equation obtained characteristic equation obtained from this equation. So how we obtain the characteristic equation? By substituting, for instance, d upon dx replacing by d upon dx by capital D, or capital D replacing by any arbitrary variable, so that we can get a characteristic equation, and just we can solve the characteristic equation by using the any ordinary technique to find the roots. And when you will get the roots of the equation, the root might be something like that. There are various kind of roots, such as roots might be real and distinct. This is the very first case. If the roots of the equation are real and distinct, then the general solution of the equation becomes y is equal to c1 plus r1x plus c2 exponential r2x and so on. It is depends upon the roots, how much roots we are getting from the equation. If equation is sort of second order differential equation, so that you will get the two roots. If equation is the third order differential equation, you will get the three roots. So if the roots are real and distinct, then solution can be written as y is equal to c1 e exponential r1x plus c2 exponential r2x in case of two roots. If there are three roots, one factor will be increased, that would be c3 exponential r3x. The second case is when the roots are repeated and the real. In that case, when the roots are repeated, you can write the solution of the differential equation for the repeated roots. Y is equal to c1 plus c2x plus c3x square and so on into exponential rx. What is rx? R the repeated roots. R are the repeated roots, so that you can write only the polynomial with the decrease in the increasing power with multiple of exponential power with the root. Number 3 case, when we have real, repeated and distinct roots. For example, r1, there are two roots are repeated and one root is distinct, r2. So in this case, the solution becomes y is equal to c1 plus c2x into e raised to the power r1x, because we have two repeated roots, so that we will get the polynomial in the coefficient of exponent is linear polynomial, because we have two roots repeated, and third root is distinct, so that this for the distinct one we have the third term, that is c3 exponential r3x. So this will be the general solution in case we have two repeated roots and one real roots. Now, four case of the higher order differential equation is when roots are complex or imaginary. For example, a plus iota bx. This is the uh, complex number. So in that case, you can write the solution of the differential equation in such a way that y is equal to c1 cos bx plus c2 sin bx into exponential ax, from where you will obtain the values of b and a. You can look at the real part of the complex number or imaginary number is a, and the imaginary part is b, so that from here you will extract the values of a and b and substitute here, so that you will get the solution of the differential equation in case of imaginary or complex roots. And now we are going to find the solution of a differential equation. This is example number one. It is a third order differential equation, third order homogeneous differential equation. See that d3y upon dx cube minus 6 d2y upon dx square plus 3 dy upon dx plus 10y is equal to 0. So first, how we'll pursue the solution, taking common y from the entire term, so that the equation becomes d3 upon dx cube minus 6 d2 upon dx square plus 3 d upon dx plus 10 into y is equal to 0. Now we will establish auxiliary equation from this equation, that will be consist of a arbitrary variable, that is we are considering r, so that this equation can be written as r cube minus 6r square plus 3r plus 10 is equal to 0. This is d3 upon dx cube. So for instance, d upon dx, we are substituting here r, for instance d upon dx, so that the equation becomes r cube minus 6r square plus 3r plus 10 is equal to 0. Now this is the third degree polynomial. Here you can find the roots of this third degree polynomial by using any suitable techniques. Here we are using synthetic division method, which you already know about how to find the roots by using the synthetic division method. We can see that when we will substitute minus 1 in this equation, the left hand side and right hand side would be equal. Therefore we are starting finding the root from minus 1. So taking the coefficients, the coefficient of r cube is 1, this one, and r square is minus 6, r is 3, and the constant is 10. Now we are going to divide by minus 1. This one will remain same, so that minus 1 will multiply by this 1. So minus 1 multiply 1, that would be 1. You will write here, and now add these two terms, that would be minus 6, add minus 1, that would be minus 7. Now minus 7 will again multiply by minus 1, so that it will be shift here. So minus 7 multiply minus 1, that would be plus 7, 7 plus 3, that would be 10. Now 10 multiply minus 1, that would be minus 10. You will transfer here, and minus 10 plus 10, that would be 0. So the remainder is 0. Now the remaining polynomial would be what? They consist of second order, that would be coefficient of r square, coefficient of r, and the constant. So we can write it as remainder, that would be r square minus 7r plus 10 is equal to 0. Now the polynomial is divided into the factors. The factors becomes r plus 1, r square minus 7r plus 10 is equal to 0. Why this is r plus 1? Because we substitute the first value of r, that is minus 1, though r is equal to minus 1 means when we will shift is at the right hand side, that would be plus 1. So our first factor is r plus 1. Now from here r plus 1, you getting the same value we consider here for starting the solution of the synthetic division. So that is r is equal to minus 1. From the rest of equation, r square minus 7r plus 10 is equal to 0. We are getting two roots, that's r is equal to 2 and 5. So that we have three distinct roots, minus 1, 2 and 5. Now roots are real and distinct, so that the solution of this differential equation would be what? The solution of differential equation, that would be y is equal to c1 exponential r1x plus c2 exponential r2x plus c3 exponential r3x. So the value of r1 is minus 1, value of r2 is 2, and value of r3 is 3. So the solution of this differential equation, that would be y is equal to c1 exponential minus x plus c2 exponential 2x plus c3 exponential 5x. This is the solution of this third order differential equation. Now in the second example, we will try to explain you more regarding the different kind of solution. We have a third order differential equation in this form: d3 minus 6d square plus 12d minus 8 into y is equal to 0. Look at this from the first example. Here in the first example, it was in the differential form, and we take common y from the entire polynomial. Here you do not need to take the common because already y is taking already common here, and replaced capital D, for instance d upon dx, so that the equation is d3 minus 6d square 6d square plus 12d minus 8 is equal to y into minus 8 into y is equal to 0. Now we will write the auxiliary equation or characteristic equation of this differential equation, that would be r cube minus 6r square plus 12r minus 8 is equal to 0. This equation is also a third degree equation, so that we will find the roots of this equation by using the help of synthetic division method. So the coefficient of r cube is 1, r square is minus 6, r is 12, and the constant is minus 8. So by taking all the coefficients, and we can see that when we will substitute 2 in the equation, the whole equation will be equal to 0. So the first root we always consider on the basis of hit and trial by substituting any number. Because I substitute 2, then I get the 0 at the left hand side, so that left hand and right hand is equal to become similar. So I would like to start from minus 2, substituting plus 2. Now the first root is 2, so 1 will remain same. Now 1 multiplied by 2 will get plus 2. This 2 will be added in minus 6, that would be minus 4. Minus 4 will multiply by 2, and we will get minus 8. Minus 8 will write here, and this will be add in 12. 12 minus 8, that would be 4. 4 multiplied 2, that would be 8. So plus 8 minus 8, that would be 0. So the remainder is 0. The remaining coefficients are 1, minus 4 and 4. These are the coefficient of second order polynomial, that would be 1r square minus 4r plus 4 is equal to 0. So from this equation, second order equation, r square minus 4r plus 4 is equal to 0, we will get the rest of two. First root is r1 is 2. Now rest of two values we will get from here by breaking the middle term, minus 4 minus 2 minus 2, taking common r, so that you will get r minus 2. From these two terms, taking common r, remaining r minus 2. Now again taking common r, so that we have two same factor, r minus 2 and r minus 2 is equal to 0. So here we have two values. So look at this. Here we have got the all three roots, that are 2, 2 and 2. All three values of roots are similar, so that in case of similar roots, how to write the solution of equation? In this case, you will write the solution of this equation. Because we have three similar roots, so the solution becomes y is equal to c1 plus c2x plus c3x square exponential rx. So what is r? R is 2 here, so the solution would be exponential 2x. Now in example number 3 is a fourth order differential equation. Look at this, d4y upon dx4 plus 2 d3y upon dx cube minus 2 d2y upon dx square minus 6 dy upon dx plus 5 is equal to 0. So the characteristic equation or the auxiliary equation of this differential equation becomes r4 plus 2r cube minus 2r square plus 6r plus 5 is equal to 0. So this equation, we will again use the scientific division method by taking the coefficients. The coefficient of r4 is 1, r cube is 2, r square is minus 2, r is minus 6, and constant is 5. Now we will start to divide from minus plus 1, because now when we are substituting 1, left hand side and right hand side become 0, so that we are starting the scientific division from substituting the value of r is equal to 1. When we will substitute r is equal to 1, this 1 will remain same. 1 multiplied by 1, that would be 1 plus 1 multiplied by 1, 1. We'll write 1 here. So 2 plus 1, that would be 3. 3 multiplied by 1, that would be 3 ones are 3. And plus 3 minus 2, that will be, if you will edit these two terms, you will get plus 1. 1 multiplied by 1, again that will be 1. Now minus 6 plus 1, that would be minus 5. Minus 5 multiplied by 1, that would be minus 5. So minus 5 plus 5, this will be equal to 0. So the remaining term will be consist of third order degree, that would be 1, 3, 1 minus 5. So again we will start to divide by 1. So this 1 will remain same. 1 multiplied by 1, that would be 1. 3 plus 1, that would be 4. 4 multiplied by 1, that would be 4. So 4 plus 1, that would be 5. 5 multiplied by 1, that would be 5. Plus 5 minus 5, that would be 0. So that remainder is 0. The coefficients of the remaining polynomial are 1r square plus 4r plus 5 is equal to 0. So the two roots we obtain from the division is 1 and 1. So the two repeated roots are r is equal to 1 and 1, and the remaining polynomial is r square plus 4r plus 5 is equal to 0. From this polynomial, it is now we are using to find the roots of this equation the most famous quadratic formula. From the quadratic formula, r is equal to quadratic formula minus b plus minus b square minus 4ac upon 2a. By using this formula, so b is 4 minus 4 plus minus b square, that is 16, minus 4ac, that would be 4 multiplied by 5, that would be minus 20 upon 2a. 2a is 1 here, so 2 multiplied by 1, that would be 2. Now after solving this factor, when you will substitute 16 minus 20, that would be minus 4, and root of minus 4 is becomes 2 iota square. Iota square will be cancelled from the square root, so that it will be what? It will be 2 iota. When you will taking common 2 from this factor, so one step is missing here. So if you like to add one step, I will show you here this step how. That would be 2 iota, and here is the 4, and in the denominator is 2. So that taking common 2 from the numerator, that would be minus 2, and plus minus iota whole divided by 2. This 2 will be cancelled out, so that you will get r is equal to minus 2 plus minus iota. Now our these two roots are complex root. In this case, how to write the solution, general solution of the differential equation? We have two repeated roots, r is equal to 1 and 1. These two roots are repeated roots, and the rest of roots are complex roots. So in this case, the general solution of this equation becomes y is equal to c1 plus c2x exponential rx. What is r? These are for the similar roots, plus rest of solution is for the complex one, that is minus 2 plus minus iota, that is c3 cos bx. What is b? Coefficient of iota. Iota is b, that is 1. So 1x plus c4 sin bx, any 1x into exponential ax. What is a here? Minus 2. So that would be exponential minus 2x. So this complete result. That would be the solution of this differential equation. मुझे यकीन है कि मेरे ये एफ़र्ट आप लोगों के लिए जो है वो थोड़ी-सी हेल्पफुल होगी। अगर इसमें कोई भी आपको लगे कुछ ख़ामी है तो कमेंट्स के ज़रिए मुझे ज़रूर आगाह कीजिएगा। और अगर आपको मेरी ये काविश, मेरी ये एफ़र्ट अच्छी लगी हो तो मैं आपसे गुज़ारिश करना चाहूँगा कि मेरी वीडियो को आप लाइक कीजिएगा, सब्सक्राइब कीजिएगा, ताकि और भी स्टूडेंट्स तक ये मेरी वीडियो पहुँच सके और दीगर स्टूडेंट भी इस वीडियो से फ़ायदा हासिल कर सकें। जज़ाकल्लाह, बहुत बहुत शुक्रिया।